Hello everyone, it's me again, Engineer Magkuyaw, and we're now going to close our topics about vector spaces, basis, and dimension. For this module, we address the course outcome, determine a basis of solution to systems of linear equation. Our takeaway would include an ordered n-tuple represents a vector in n space. For instance, an ordered triple has the form x sub 1, x sub 2, x sub 3. An ordered quadruple has the form x sub 1, x sub 2, x sub 3, x sub 4. And a general ordered n-tuple has the form x sub 1, x sub 2, x sub 3, up to x sub n. The set of all n-tuples is n space and is denoted by r raised to n. An important type of problem in linear algebra involves writing one vector x as the sum of the scalar multiples of the other vectors v1, v2, and v sub n. That is, for scalars c sub 1, c sub 2, up to c sub n, there exists the vector x, which is equal to c1, v1, plus c2, v2, plus, and so on and so forth, plus c sub n, v sub n. The vector x is called a linear combination of the vectors v sub 1, v sub 2, up to v sub n. A non-empty subset W of a vector space V is a subspace of V when W is a vector space under the operations of addition and scalar multiplication defined in V. Let S be equal to V1, V2, V3 up to V sub k to be the set of vector space V. The set S is a spanning set of V when every vector in V can be written as a linear combination of the vectors in S. In such cases, it is said that S spans V. A set of vectors S is equal to V sub 1, V sub 2, V sub 3, up to V sub k in a vector space V is linearly independent when the vector equation C1V1 plus C2V2 and so on and so forth plus CKVK is equal to 0 has the only trivial solution. And lastly, a set of vectors S is equal to V1, V2, up to V sub n is a vector space V is a basis for V when the conditions below are true. 1. S should span V, and 2. S is linearly independent. The row space and column space of an M by N matrix A has the same dimension. The dimension of the row or column space of a matrix A is the rank of A and is denoted by rank of A. I hope that everybody learned a lot from this module. See you again for Module 3. Bye!